So these two problems are asking us to solve these inequalities, and they're using what's called a sign test. And so first of all, let me explain what they mean by sign test. Well, what they mean by solve the inequalities. They're basically saying what values of x make this inequality true. So you could just plug numbers in and hope to get kind of a rough idea. Does 0 make it true? If I plug 0 in for x, I'd get negative 15 is less than or equal to 0, and that's true. So 0 is a solution. If I plugged 1 in, I'd get 1 squared, which is 1, plus 2 times 1, which is 2, minus 15, which is still negative, right? Negative 12, which is less than 0, so that works as well. So 1 is also a solution. But eventually you're going to get to a number, let's see, 5. If I plug in 5, 25 plus 10 minus 15, well, that's bigger than 0. So that is not a solution. You understand? So how do you do this algebraically, meaning systematically? How do you solve this inequality? How do you find the solution? And the best way to do it is with graphical analysis. So if you could imagine this in a two-dimensional graph, pretend like that was saying x squared plus 2x minus 15 equals y. Then that's going to be, you've graphed these quadratics before, that's going to be a quadratic equation. It's going to be opening which way, up or down?
Is it up?
It's up because the leading coefficient is 1. Very good. And so it's going to be something like this somewhere. I may not have put it in the right place, but it's going to be some sort of quadratic equation. And so where is the y greater than or equal to 0? I'm sorry, less than or equal to 0. Because that's what they're saying. Where is this equation less than or equal to 0? Well, it would be all of these values right here.
Mm-hmm.
So your solution would be whatever this point is and whatever that point is, and because it says equal to, it would include those 2 points. And so it would be all of those values, whatever that was. Let's call this A and B. It would be everything between A and B. So you would write A is less than or equal to X is less than or equal to B. So we have to find A and B. We have to find those 2 values.
Mm-hmm.
So let's do that. So to do that, we're going to graph it, and we're going to actually factor. We're going to really finding the zeros of this equation. Imagine this is an equation now. To finding the zeros, the best way to do that is to factor if possible. So let's factor that. Well, this x squared is x times x, and negative 15 is negative 5 and positive 3, or 5 and negative 3, or 15 and negative 1, or negative 1 and 15, or whatever. You understand the different ways you can factor that.
Yeah.
And do any of those add to positive 2? Well, these two do.
Yep.
So it's going to be plus 5 and minus 3.
Mm-hmm.
And so that means that my x-intercepts are what?
Positive 3 and negative 5.
Positive 3 and negative 5. Positive 3, negative 5 if I set them equal to 0. So those are my 2 values. It was negative 5 and it was positive 3. So that's my solution.
Okay.
So if you had plugged in a value that was somewhere between there, and remember we had those test points, and remember 0 worked, 1 worked, 5 didn't work.
Mm-hmm.
Negative 5 will work though,
Yeah.
because the negative 5, that negative times the positive gives you a negative 10, and that square gives you a positive 25. So you can see, oh yeah, that does work. That's exactly equal to 0. So there's your solution. Let's do that for number 2 now. Well, number 2 is easier because they wrote it for us in factored form.
Mm-hmm.
But it's a little bit harder because we've got some squareds here. And so this is where understanding graphs, analyzing graphs, graphical analysis really comes in handy. So if you remember what this means when it's called multiplicity 2, you're familiar with that phrase? When there's a 0, you've got x equals 1, or x equals negative 2, or x equals 3. Right? Those are my 3 zeros that I have.
Mm-hmm.
But these 2 zeros are multiplicity 2, which means it bounces off of that.
Okay.
So think about what your graph is. I like to look at my solution in 2 dimensions personally. It just makes more sense to me to do that way. Sign analysis is really talking about using one dimension, like using just a real number line, just the x-axis. That's what they're suggesting that you do here, is just like use the x-axis like this. Let's see, -2, 1, and 3. They're suggesting that you do this and find values in between here, and that tells you when the graph is going to be greater than 0 or less than 0, because all of those values are where it touches 0.
Yeah.
Right? But in my opinion, it makes more sense if you know how to analyze the graph. It makes more sense to do it like this. Here's -2, here's +1, and here's +3. Just do your sign analysis in your end behavior. This is going to be a power 5 equation. This is an x to the 5th equation, and the leading coefficient is positive. So you know it's going to be going like this. Down on the left, remember this sign analysis, and up on the right. Okay? So since that's happening, and since you know it's going to do what at -2? What did I say it does at -2?
It's going to bounce.
It's going to bounce. So it's going to go up like this, and it's going to bounce and go down. And then at some point it turns around and goes back up. I don't really care where it turns around for this problem. It's going to go back up, and is it going to bounce or go through at -1? I'm sorry, at +1.
It's going to bounce.
It's also going to bounce, and then it's going to come back up at some point, and what's it going to do at 3?
It's going to go through.
It's going to go through. So the question is, when is the value, look at what this says up here, when is that value greater than 0? Not equal to, when is it greater than 0?
After 3.
It's only greater than 0 after 3. So only when x is greater than 3. And there's your answer for that one. You don't include equal to because it equals 0 at those, and you don't include any of these because it equaled 0, but it never went positive. And they're only asking when it is positive, greater than 0.
Okay.
Make sense?
Yep.